So in my last video, I set my power supply to 10 volts, which we'll see across the rail here, 10 volts there, and I set the output of the trimpot to about 5.7 volts. Not exact, but about that. It's a voltage divider. We can get a fraction of the power source voltage. Then I took an NPN bipolar junction transistor. This is the 2N2222. Emitter is to the left, base is to the middle, and collector is to the right. So we want the emitter down lower on the board. We'll just turn it this way. The base we want to the trimpot because you use signals from other components often to connect to the base, which sets a small current depending on what you're doing to the emitter and goes to ground with an NPN, and that's how you control how well the transistor conducts oftentimes. Now we're going to connect the positive rail to the collector of the NPN bipolar junction transistor, and should be able to see that there. So metal pin is to the trimpot, the collector is to the positive rail. So I'm going to use a 470 ohm resistor. We will see why coming up. I'm going to connect that to the emitter of the transistor. So now the transistor is conducting, but the main thing is, remember we set the trimpot to about 5.7 volts, just a tad bit above that, and so we're going to lose about 0.7 volts from base to emitter, but otherwise we will have about 5 volts. There we go, at the emitter right there. And so that is set by the trimpot plus the resistor that goes to the from the emitter to the negative rail. So it is blocking current to a point, and so there's a voltage buildup based on the trimpot because the transistor can conduct however well it needs to hold that voltage there. Now we are going to open up the circuit. So now the collector is not connected, and so we'll have a different voltage here because all of the power is coming from the trimpot and it has high resistance, and so it's going to throw things off. But we're going to set the meter to measure milliamps of current. And this is an auto ranging meter that beeps really loud, and the red probe we only have to move if we ever measure really high currents. So as long as we're in the milliamp range, we can keep the red probe there. So that's better than the Lyumi meter where I have to keep making changes within the milliamp range. But they did update the Lyumi meter, and it looks like they turned it into an auto ranging meter. So I'm thinking about buying that and showing the differences. But in any case, we have the meter set to measure milliamps, and we're going to go to the red probe. As you saw earlier, we had it connected directly to the collector. Now we're going to come up to the collector. Now you can see we have about 10.75 milliamps of current. So that's about what we'll get in that range if we take about 5.1 volts or so and divide it by 470 ohms. That's what this resistor is, 470 ohms of resistance. But in any case, we can look at that number, the 10.79 milliamps. So right now I'm directly connecting the jumper there to the collector. I'm just connecting it through the meter. So it's up one spot from the trimpot, and I'm just connecting it like that. So what I'm going to do, I'm going to add one LED, so the long lead the anode to the positive rail, short lead the cathode down one. I'm going to put it there, and we will zoom back, and now we're going to complete the circuit through the LED. Remember we had about 10.8 milliamps, and right there 10.8 milliamps of current, even going through the LED. Now we'll add another LED, and as long as you have enough voltage, you can keep adding more load. So I'll put the black probe to the collector of the transistor, and then the red one to the cathode of that LED, and you can see it's the exact same current. So because we set a voltage, which we looked at in the last video as an emitter follower, the collector is going to pass whatever current it can up to whatever limit it can to hold that voltage there. And so even if we change the load on the collector side of the transistor, it's going to pass the same amount of current. Again, as long as there's enough voltage. We have 10 volts at the power supply rail, so we have a bit extra to play with. And so we could light more LEDs than with 5 volts directly. But for this topic, just be aware, we made a current source. So when you hear current source, that's what it means. Your load is getting a certain amount of current. Even if you change the load, it doesn't affect the current unless your load is too big and it can't provide enough power. So thanks for watching, and I will see you in the next video.